I'll be covering problem 12 on the Unit 2 test review key. So it says for number 12, using the domain from 0 to 10, let A equal the even numbers. So your first job is to come over here and where it says A equals, start with the brace and write the set of even numbers contained between 0 and 10. Those numbers are 0, 2, 4, 6, 8, and 10. We have to stop at 10. All right, then it says B, let B equal the multiples of 3 from 0 to 10. So 0, 3, 6, and 9. So that's your first job, is to write those sets. Then for part A, it's asking you to find the intersection of sets A, B, and C. Remember the symbol that looks like an upside down N is an intersection symbol, which means to find all the elements that all three sets have in common. In a Venn diagram, it would be the middle section where the three circles overlap. So that's what I did. I created a Venn diagram of all the elements in sets A, B, and C. And you can see the only elements that overlap are 0 and 6. If you want, you can just look through your list and go, well, what numbers do sets A, B, and C have in common? So they have 0 in common, and these are multiples of 3. Over here, I have some multiples of 3 and some that are even, but the next one is just a 6. So I've got 0 and 6 so far, and it appears that that is it. But that's really what you're looking for. So you don't have to create a Venn diagram, but if you do, it would be where the three overlap. So I'll just draw a quick circle. It's where if you drew a Venn diagram, all three would overlap. Next, you're asked to find what's left when you take the elements in C and subtract out the elements in A. My recommendation would be to write out the elements in set C and then subtract out the elements in A, which are even numbers up to 10. So we're taking C and we're subtracting even numbers up to 10. So if I take out the even numbers up to 10, I'm going to take out 0 and 4 and 6, and I'm going to stop and not take out 12 because it's above 10, and A only contains even numbers up to 10. So my resulting set would be 9, 12, 14, and 19. Now on a Venn diagram, what that would look like is if I took C and subtracted out A, I would look only at circle C, and I would subtract out anything contained in A. Well, A is this circle up here. So if I take out A from circle C, that means I'm taking out 4, 0, and 6. So what's left is 9, 12, 14, and 19. Next, for part C, I am starting off with set C, and I am taking out elements that A and B have in common because this is an intersection. So we need to think, what elements do A and B have in common? Well, if we look at sets A and B, the only things they have in common are 0 and 6. So that means I'm going to take the set of elements in C and subtract out a 0 and a 6. So I'm just going to look above here in set C, take out 0 and 6, and what is left are the elements 4, 9, 12, 14, and 19. So again, with our Venn diagram, if I consider circle C, all the elements in circle C, if I take out what A and B have in common, A and B have in common 0 and 6. So if I remove from circle C the 0 and 6, I have 4, 9, 12, 14, and 19 left, and that's what we wrote, 4, 9, 12, 14, and 19.